Welcome back. In this video I'm going to be showcasing my completed memory system that can store up to 1 megabyte of data. Just due to a game limitation, nothing of the system itself. I can easily expand it to be much larger, but I doubt I'll ever actually use 1 megabyte of storage in this game, ever. So let's get into it. Let's start by populating our hard drive a bit. We're just going to generate some empty data. And let's go ahead and talk about what this block is up here. It is a set of RAM. Now this is a fixed position set of data, is at 16, 16, 16, so I can easily address to it. And in it are 7 objects that I can use to store information. Now, the read-write system can only read from the first RAM address, and it cannot read the rest. So the RAM system has a memory swapping functionality that allows me to move information around within the data of the RAM, as well as, just ready it for reading and writing and everything. Let's go ahead and just cut it off at about 1,000. We're going to let it run for a little bit longer. As well as I've done some optimization to this. As you can see, it's running a little bit less commands than before. It's also running in a different direction. If you recall from the last video, which I will have linked in the description down below, this was running from left to right, or from right to left to where I'm standing now, instead of from right to left facing this way. The pillar of disappointment is that way. And this was just due to me being stubborn, and I decided I should just finally get over it and change how my decimal to hexadecimal system works, which I have updated the conversion to read up to 8 values, which is the absolute maximum that you could ever use for hexadecimal conversion in Minecraft due to the maximum value scoreboards can hold. I'm not going to get into that. The hexadecimal system, the hexadecimal conversion system, I might get into at a later time, but not today. I'm also not going to get into depth about this because, as I said, I've showcased it before. The only thing I've changed is the direction, as well as removed a few unnecessary commands. There were 1 or 2, if I recall correctly. But let's go ahead and write some data. What we have right now, if we look at what we have in storage, we have some objects. We also have some number objects. As you can see right here, we also have strings, we have arrays. We have really anything we want we can write into this RAM system. And what we can do with that is currently we have is data in slot 0. So let's go ahead and write that. Let's just do a trigger. As I said, I was going to write this all into triggers. Let's write the data. And as you can see, what we have here is we found an address at 1079. Then we converted that decimal of 1079 to the hex value, which is 437. And that is out of 8 addresses here. This is X, Y, Z. Otherwise, we have A, B, C, D, E, X, Y, Z. Actually, no, it's A, B, C, D, X, Y, Z, and then the remainder. Sorry about that. I sometimes get confused when talking about that system. What we have after that is we have our data here, which we can read. As you see, it is data. Now let's go ahead and write something different. What we do then is trigger, and we're going to do a RAM swap. Now the RAM swap works by inputting 2 numbers, or just 1 number if you're swapping with the slot 0. So let's say we want to take the information that is in slot 3 currently. What we do is we do a RAM swap set to the value of 3. That will swap the information that is in slot 0 and 3. The reason it is 0 and 3, we can, of course, do 30 as well, which will swap the data in the RAM slots 3 and 0, which does the same exact thing. So for ease of use, if you are just swapping information in and out of the 0 slot of the RAM, you can just input a single number. Now let's go ahead and take that information that we wrote, which is currently the numbers 99999L. And let's go ahead and write that into storage, and let's go ahead and read that. And we're going to, whoops. Do I have that? I do not. Okay, so let's actually read, because I haven't done read yet. So to read, what you do is you trigger the read data, and you set it to the memory address you want to read, which currently is 1080. That is 1880. 1080. Let's go ahead and read that. What we have here is we've converted the decimal value that we've inputted to the hex value. As you can see, is the same as here. And we have copied the output. As you can see, it's right there. Let's go ahead and read the information that's in RAM. As you can see, that numbers is right here, and if we go to 3, it is data. Now we can just shuffle information all we like, but that's going to get old pretty quick. So let's go ahead and get into the actual functionality of everything. Now that we've showcased, let's actually look at one last thing. I do have a delete data board, delete address, and then you set it to the address you want to delete. Let's delete our address 1080. And doing that just removes that memory address, allowing it to be used later. That also allows me to input any memory address I want. Let's say just input 1045, then we clear that one. So we can input any data we want, and it will convert it and delete it. So let's get into the files. Let's go ahead and switch over to them. What we have here is the read and write functions. I have them side by side because they do start out fairly similar. I'm going to discuss their differences because they do end up very similar as well. They don't use many functions overall, so we're just going to talk about them together because they are fairly similar. What we have here is both of these are the trigger that are the functions that get set off whenever when the player triggers the scoreboards, which just right here re-enables them. The reason for read data, I'm setting it to -1 because 0 is a memory address. What we have here is our read data, or read write write, and read write read. Tongue twister, that is. Next we have these two, which are fairly similar as well. What we're doing is we are taking the seek address, we are running that, then after that we are taking that value that we received from the seek address, which, as you can see, if we go back here, the value we're receiving from the memory address is this one right here, this 1080, and then it's placed into the hexadecimal converter. I have an output just to make it easier to explain. What we have after that, as I said, we then convert it, and then we run a set of functions here that are also the same here. The only difference is we are taking that read data from the player that's been inputted and putting it directly into the calculation. It's the same exact score as we are using here because it is the same information that needs to be given. After that we have the subhead here. This summons the armor stand that's used for reading and writing data. This is the same command on each one's because it's the same entity. What we have here is the armor stand that gets summoned. It has a custom name and a tag, as well as some armor or an item in its head, which is just some stone, and in that is a storage tag that currently is not used for anything but can be in the future, which is why it is there. And what we have after that is we have the placehead function, which just takes the score that is outputted as the X, Y, and Z values from the hexadecimal conversion and places it into the position values of the entity, respectively to X, Y, and Z. Then after that, we have our placements for our write information. We are placing a block, an empty jukebox with that storage tag, and then we are taking that block and we are putting the information from the RAM, which is block 16, 16, 16, and slot 0, and we are placing it into that jukebox. And that's how the write works. Now for reading, it's just in reverse. We are taking that information taking the information of that record item that it is in. Oh wait, no, that's this. What this is doing right here is clearing slot 0, just in case there's some weird data there that doesn't want to be overridden by a full set of information. Then what we're doing is we are placing the information into the RAM, into its slot 0, from the block that the entity is in. And then of course at the end we are killing the entity. Now that is both of those. Now let's look at the RAM, because this is a completely different system that runs independently and operates on its own, operates under different values. What we have here is the RAM swap function. This is run by the trigger scoreboard, which is also RAM swap, just for ease of use. For me, what we're doing is the first command, if the value is above the maximum possible value for a memory address in the RAM, which is 77, for swapping data from the 7th slot to the 7th slot, which is ultimately useless, but you might as well have it just there. And then what we're doing is we are taking that number, if it was changed or not, and we are placing the player's RAM swap into the actual address's RAM swap. This then gets converted using the get address number. This takes that two-digit number and converts it into two one-digit numbers in values A and B, and those are used in the copying. This right here just separates them, and this is actually using fundamentally the same way that I do my hexadecimal calculation, which, as I said, I might showcase later. Then what we're doing after that, as you can see right here, we are then running copy and paste. These are two fairly similar functions. As you can see, they are basically the same thing. They just have copy and paste. And then we have the A and B. This is what copies A looks like. The only difference between A's and B's is this letter here and this letter here. As you can see, the highlighted A. Those are the only things that are different between the two. What we have is based on what the RAM swap for slot A, or for the A value is, based on what that is, it will place the information that has stored in copy.A into that specific RAM slot. And then what it'll do after that, in the paste function, it does the same thing, just in reverse. Or not in reverse, just with the B value instead. Everything else is the same. And that is it. The difference between the A and B paste functions that is noteworthy is the A's and the B's are swapped at the beginning and end of the command, just because we are actually swapping the information after all. But that is everything. Hopefully that was comprehensible. This is a rather long explanation as well. It is a rather complex system. And kind of want to talk for just a moment at the end of the video. I currently have no use for this. As I said, there is very little that I can actually use this for, and I doubt I will ever use even 1 megabyte of storage. But I want a challenge. So if someone can think of something that would be interesting for this to do, and I could possibly find a way to do it, I will try my best to do it. One of my current ideas is making data packs with the system. It sounds stupid, but I have my methods, as well as some other things. Mostly entity storage is what this is useful for. Entity and data storage, which is ultimately something you can do really with anything. So this has a lot more potential than it's good for. But yeah, hopefully that all makes sense. If you have any ideas to use this system, please go ahead. If someone asks, I will probably provide a download link. I have shown all of the code, and I'm not insecure about my code at all. So, yeah, that's it. So thanks for watching, and I will catch you all next time.